All right, we are going to get started. It is 3 o'clock. So welcome to the 2020 Watershed Congress. Today is Friday, day 5 of our virtual Congress week, and we are so very excited for you to join us today, wherever you may be in the world. The Watershed Congress is organized by the Delaware Riverkeeper Network in collaboration with organizations like Stroud Water Research Center, who is moderating and presenting your session today as part of our mission to advance knowledge and stewardship of freshwater systems through global research, education, and watershed restoration. My name is Mandy Nix, Watershed Education Specialist at the Stroud Center and member of the Watershed Congress Organizing Committee. I am also your moderator for this session, updates and improvements to the online water quality modeling application, Model My Watershed, with Dr. David R. Scott, Executive Director and Research Scientist at Stroud Water Research Center. Before I turn the session over to Dave R. Scott, I have a few quick announcements. First, I would like to pause briefly in recognition of the myriad organizations, individuals, and partners who have made today's program possible. This is the first ever virtual Watershed Congress, so thank you to these partners. For this presentation style session, we will be taking audience questions after the presentation by our speakers. We will be using the question and answer feature in your bottom toolbar to take questions, so please post any questions you have there throughout the remainder of this session. The chat will be open for comments during the session, and I will be posting guidance for using the chat feature shortly. This presentation is being recorded. Recorded presentations will be made available on the 2020 Watershed Congress playlist on the Delaware Riverkeeper Network's YouTube channel. You will receive an email when presentations from this week are posted there. Finally, this week we'll be using the hashtag Watershed Congress for social sharing on Twitter or Facebook. It is at last time for our presentation. Updates and improvements to the online water quality modeling application, Model My Watershed. I am so pleased to present today's speaker from Stroud Water Research Center, Dr. Dave R. Scott, Executive Director and Research Scientist, whose past research focuses include aquatic primary production, distribution and diversity of aquatic macroinvertebrates, ecohydrology, and the ecology of rivers and floodplains. Dave, I turn the presentation over to you.
Thank you, Mandy, for the nice introduction, and good afternoon, everyone. Welcome to 1 hour update on Model My Watershed. For those of you who are not familiar with Model My Watershed, you can find this application and use it for free online at wikiwatershed.org or go directly to the app through modelmywatershed.org. The application itself has been developed over about 12 years now with contributions from many collaborators locally and around the country, and to name a few on the title slide there. And I'll get into the introduction of what Model My Watershed is in just a moment. Just want to explicitly recognize the team members that have contributed quite a bit of time and effort for the development of this app, as shown on the screen here. As I mentioned, you can access these resources at wikiwatershed.org. There's a variety of online resources relevant to watershed ecology, watershed management, etc. on Wiki Watershed, and you can find links to Model My Watershed and another partner app called Monitor My Watershed. Today I'll just be focusing on Model My Watershed. The suite of tools, many of them made available under Wiki Watershed, have strong history of funding from the various funders. I'd like to acknowledge them before we get started. Most recently, funding from the William Penn Foundation, specifically targeted to enhance tools available for those people involved in the Delaware River Watershed Initiative. So what is Wiki Watershed? It's a web toolkit to support the public, broad audience from citizens to conservation practitioners, educators, students, to cleverly advance knowledge and stewardship of our environment and fresh water. Today, what I'd like to do is go over a brief introduction of Model My Watershed. We'll go online and use the tool live in just a moment. and highlight recently released features. And if there's time, I'll share some examples of projects where we've used these tools for conservation and restoration planning. Probably won't be time, but I still like to mention that the project work you do in Model My Watershed can be exported to a third-party archival and sharing service called HydroShare, available at hydroshare.org. And if I don't get a chance to talk about that today, you can find out more information in our technical help document resources online. We've also integrated some other modeling tools I won't have a chance to talk to, but those within the Delaware River Watershed Initiative may be familiar with SRAT, or Stream Reach Assessment Tool, which we've embedded into Model My Watershed, called Hotspot or Subbasin Model. So this slide just shares with you the suite of tools that are available under Wiki Watershed. As I mentioned, there are several. We'll focus on Model My Watershed today for watershed modeling, analyzing geographic information, running hydrologic models and nutrient runoff models, and comparing conservation and development scenarios and how resulting nitrogen, phosphorus, and sediment loads, as well as runoff and infiltration change with changing conditions like land cover or implementing best management practices. From the inception, Model My Watershed's vision has been to provide an easy to use pro-grade modeling package to inform land use decisions. And we've always had a focus on the easy to use part, although you'll see that the web application is becoming a little bit more complex as we add more and more functionality. And as mentioned, it's freely available. You can see many different layers for the contiguous United States in Model My Watershed, and you can extract information from these layers that are then subsequently used for modeling. Here I'm just illustrating the primary data layers from stream network to temperature and precip, elevation, slope, the hydrologic soils group, and the national land cover database. Right now, that database is linked to the 2011 product, but we hope within the next 6 months we will be upgrading to the 2016 National Land Cover data set. What you won't be able to visualize, but is embedded in the back end of the modeling application and informs the watershed multi-year model are estimates from the USGS for ACE flow, it's linked to groundwater nitrogen estimates, soil phosphorus estimates, soil nitrogen estimates, and you can actually visualize the weather station network that we have that is preloaded into Model My Watershed, and the red points are the geographic location of these long-term climate and weather monitoring stations around the country. So with Model My Watershed, one can analyze land cover and many of those data layers that I had just shown. I'll share with you protected areas and active river area layers in just a moment. You can save and share your work and compare scenarios as you build out possibilities for a parcel on the ground or a watershed. Within Model My Watershed, there are two primary models, and the primary differences here are the site storm model tends to be most appropriate for smaller scale, less than 1 square mile down to maybe 4 acre parcel, 3 acre parcel. So that's the site part of the title, and then site storm model refers to the fact that you would be modeling a 24-hour rain event, and you can change the intensity of precipitation and then follow the changes that occur with runoff, infiltration, evapotranspiration, and sediment and nutrient load runoff. The watershed multi-year model package is more appropriate over larger spatial scales at the watershed level, and in its name, multi-year refers to the fact that the weather data that inform the model are annual data. In most cases, it's 30 years of daily data that the model uses to produce annual and monthly load estimates. So it's over a longer time horizon than the site storm model, and typically results are viewed in annual output. We've recently added, and I'll touch on this with some visualizations, just in this year, 2020, we've added the ability within the Delaware River watershed to analyze a prediction of future development that comes from folks at Shippensburg University, future development being predicted for the year 2100. We can analyze the active river area, protected lands layer, and then most recently, we have updated the watershed multi-year model so that the user could upload their own weather data, temperature and precipitation, and automatically use an estimate of future climate, future weather for the Delaware watershed geography. And that links to that future development. The predictions are for future daily temperature and precipitation in the year 2100. There are other possible future releases that are forthcoming as well that are listed there. This is an open source software project, and we share much of the code and details on all the data layers through a Github repository. And I'll show you where you can link that if you're interested in accessing the detailed backend information. So here's where I click over to the internet, and we'll start with wikiwatershed.org. So let me just flip over there. So now we're in a browser, and this is wikiwatershed.org landing page. We'll be clicking on Model My Watershed and launch the app in just a moment. But before I go there, I'd like to point out the help page up here on the top menu, where you can find manuals, tutorials, and other important information to help you out. So we've organized our help resources based on the tool that's under the Wiki Watershed domain. So click on View Help Resources for Model My Watershed, and you'll see a list of different resources here. Particularly like to draw your attention to Model My Watershed technical documentation. This document will provide, if not very detailed information about all the data layers and the models, then there will be links to third-party websites where you can access very detailed information on components of Model My Watershed. We may come back to that in a little bit. So for now, I'll go back to Model My Watershed, and I will launch the application. You'll notice the URL changes to modelmywatershed.org up top. So this is a standalone application that's actually running on the Amazon Web Service Cloud. We've tried to design this in a way that we call sort of breadcrumbing, an intuitive way to get users to explore a website. And you'll see that primarily the interface is map-based. If you click on the Layers tab, you can hide or show these different palettes on the Layers tab. And I'm going to click to the base maps and just point out that there's a variety of different types of base maps that you can choose. I'm going to choose terrain to start. And then you can explore each one of these layers that has the data sets that we saw from the PowerPoint presentation. So for example, we have the stream network or the National Land Cover data set with a color-coded key adjacent to the text there. Really though, what we want to do is define an area of interest that we can analyze. So we just click Get Started, and there are a number of different ways to select an area on the map. You can select by boundaries. If you don't know what USGS HUCs are. These are subbasins related to the surficial hydrology throughout the United States, with HUC 8s being a larger geography than the higher numbered HUCs. HUC 12s would be smaller watershed units. We can zoom into any area then. And when we hover over the map, we can see the name of what that hydrologic unit is called. There are a variety of other tools. You can free draw, you can drop a square kilometer. You can delineate a watershed by clicking on the map, and you can upload a file from a GIS desktop application like ArcGIS, shapefiles, or GeoJSON, if you know what those are. For now, I'm just going to select a boundary, the HUC 12, as an example, by clicking on the map. And when we do that, it tells the software to extract the data from the underlying data layers and provide a summary to the user. So it was spinning on the left side and ultimately finished its analysis for Hassler Run, Mill Creek, HUC 12 subwatershed. We can see how large the subwatershed is here. And then we have a variety of tabs related to these different geographic features. The first being the stream network statistics. We have first through 10th order streams. These are the smallest headwater streams and the largest bodies of water like the Mississippi or the Ohio River or the main stem Delaware may be in the 7, 8, 9, 10 category. So you get the total length and the mean channel slope from those data. And if you would like to download those data to a spreadsheet, you can click download and you'll be asked to save the file as a CSV that you can open in a Excel spreadsheet. You'll also see at the bottom here that we've summarized the length of all of these streams that flow through agricultural areas and non-agricultural areas. We've added this because, particularly for our work, we do quite a bit of work in agricultural setting, considering streamside activities in agricultural lands and where there are opportunities to help farmers address their land stewardship next to streams by fencing out livestock, planting trees, etc. So this gives us an indication in this geography of perhaps how many opportunities by stream kilometer there might be. There's a land cover table that gives you the categories from the National Land Cover Database in both percentage for the area as well as square kilometers here. We can sort any of these columns to bring the largest land cover type to the top. We also see the third column, data column here, fourth column, active river area, and the land cover that's broken down within the active river area. And if you're wondering what the active river area is, there's a data layer that you can visualize here on Cover Grid that shows you the active river area as defined by this data set. I'm happy to share where this data comes from at a later time or in the chat box later. In addition, with the land cover, you'll notice a drop-down box, and this is one of the new features that we've just added this year, so that one can see what the acreage is of protected lands in this area. So now the polygons have changed colors and locations to represent what we know to be protected land in very different categories, from federal, state, local, park or recreational natural resource, ag easements, and conservation easements. And you get a summary table down below. We are not, however, at this point, delivering you the land cover within those polygons. You might have noticed two other layers that you can now see under this summary tab. One is the DRB 2100 land forecast for centers. This is a brand new data layer that we have uploaded as a collaborative project from Shippensburg University, their Geospatial Analysis Center run by Claire Jantz, where she's run a predictive model to predict the future land cover within the Delaware River Basin. However, we're only visualizing on the map in red the developed land. The other details for the remaining land categories are shown in the table on the left. So the table has been updated, and now this is the land cover distribution for this future development scenario. Now the word centers here refers to the type of future development modeling scenario that was implemented. Centers refers to a constraint on new development to business centers or centers of present day developed activity, commercial and industrial activity. There is a second scenario that we've loaded up here called corridors, where development is allowed to occur also along transportation corridors out into the future. You can also download all of those data at the bottom if you so desire. Quickly, a couple other data layers in here that are important for modeling are the hydrologic soils throughout this geography, color-coded and summarized to the left. There's a terrain tab that gives you access to a elevation map that underlies the visualization system here. So for this polygon, you're seeing the average elevation, slope, minimum, and maximum. Because we had to build the color scheme for the entire United States, if you're in a small geography, you may not see much color contrast for elevation, but slope may be more useful for visualizations to see where steep and less steep slopes occur in your area of interest. We also have a climate tab that you can visualize. However, the visualization is better at a national scale than a local scale. And you can see the slider down here is also by month. But the data on the left-hand side show you the mean annual precipitation patterns in this area and the mean annual temperature, or mean monthly temperature patterns, along with those data down at the bottom. Second to last tab I'll talk about is point sources. If you have a permitted point source in your geography, let's see, I need to deselect precipitation and turn on. We have two National Pollution Discharge Elimination System permitted discharge points in this geography. And when I hover over, you can see the blue dot pop up and we can see some metadata so that you could link through and find this station on the EPA website for either of those stations. We also have an estimate of the number of farm animals that comes from the county level ag census data. This comes into play when we run one of the models. All right, so that was a fairly long introduction to just the analyze feature, but very useful information can quickly be returned to the user for your area of interest. And then if you have a desire to do some hydrologic modeling and nutrient modeling, we have the model tab that you can move on to. And we have two choices, site storm model and the watershed multi-year model. I'm going to start with the watershed multi-year model because this contains recent updates that I'd like to highlight. So when we click on the watershed multi-year model, we engage the software to start running the model algorithms. And what's happening here is the model is fetching a 30-year temperature and precipitation data file that has 30 years of daily data in it, and pushing those data through this hydrologic model. The model then partitions precipitation using land cover, soils, elevation, temperature, etc., into a prediction of stream flow, which you see on the left, or surface runoff, subsurface flow, point source flow, evapotranspiration, or you can see sort of the raw precipitation input, and you have a summary table of these statistics down at the bottom. Of course, if you want to know where the precipitation and temperature data are coming, you can turn on the weather station data and search for the nearest 2 yellow dots. And you can see that at this time, we're pulling the weather data from this particular station and the station over here near the Susquehanna. Okay, and we'll zoom back in. On the water quality side, we have average annual loads from the 30 years of daily fluxes that account for sediment, nitrogen, and phosphorus loading that would come out of this polygon or this watershed to the creek. So you get total load, loading rates, mean annual concentrations, and mean low flow, and you get the partition of those loads into the different land use, land cover categories that you can see on the left here, as well as what might result from farm animal density in this area, stream bank erosion, subsurface flow, point sources, and septic systems. And you can download those data. I'm sure there's lots of questions if you're brand new to modeling. Be happy to answer offline or in our help documentation, but just for the sake of time and demonstration, we'll keep moving on. So we've done the initial modeling run, and what we might be interested in is tweaking the model, changing the model, or building scenarios, implementing best management practices, or changing land use. And one can do that by clicking on the Add Changes to this area text over on the right-hand side. When you do that, there's a few things to note. First off, you'll see you have a new scenario over here that now allows you to diverge from current conditions. So current conditions is saved and can't be modified, but your new scenario can be modified. You can rename this to example changes. That's what I'll name it to right now. And you can begin changing things. There's lots to explore and discover here. I'm going to start with land cover. If we go back and turn on the national land cover grid and zoom in a little bit just to get a better picture. We click on land cover up here, and what pops up is the land cover table for the categories needed for modeling. This table is a little different from the land cover table you saw in Analyze because several of the categories are merged together. For example, wooded areas include evergreen, deciduous, and mixed categories. And you can see the amount of land cover in hectares in this case. I have a metric choice for my units. And they're sort of grayed out, you can't highlight them, but these would be the 2011 data that are in current conditions. So you can modify any of these numbers as long as your total continues to add up to, in this case, 4,500 hectares, and it needs to be exact. So if I, for example, take 500, 700 hectares out of woodlands, then I would have 1,082.4, and let's put 500 of that into hay pasture. So I would have 2,046.8. I should have I'm not sure I did that exactly right. Regardless of what I just did, I need to put 200 more hectares in, and I'm going to add that to cropland, which would be 8.5. And you might have to play around with the decimal to get the red go away. So now I've modified land cover, and I can hit save. and the model reruns and updates. So now I would like to do a different scenario, and I'm going to keep what I've done. So I'm going to duplicate this scenario. Duplicate is not currently working for me. Sometimes there's a little glitch that happens. So I'm rather going to add a new scenario and just title this example 2. And this time, under land cover, instead of manipulating 2011 land cover for something that I'm interested in, I am going to choose to use the forecast from the Delaware River Basin land forecast for 2100. And I'm going to choose the centers corridor. And when I click on that, this table's automatically updated based on the data in that other data layer. So this is a brand new feature that we've just added. And we can hit save. And now the model has rerun and updated all of the data. And I'll show you the comparison view in just a moment. I'm going to do yet one more new scenario, and I'm going to choose the same future forecast. But in addition to that, I'm going to, I forgot to log in. There we go. I'm going to choose the weather data tab. And this is also a very recent update as well. Available in the Watershed multi-year model only. The user can upload their own custom precipitation and temperature data. They'd have to prepare those data in Excel or a spreadsheet and have a comma separated value CSV file to then upload. Or if you're in the Delaware River Basin, you can choose from one of 2 future weather simulations that also come from our partners at Shippensburg University. RCP 4.5 is from the global climate models. It's an average of something like 11 or 14 global climate models for a mid-range estimate for greenhouse gases in the year 2100. And technically, we are choosing a data file that has daily temperature and precipitation produced for every day between 2080 and 2099. So there's 20 years of daily data in this preloaded file that you would be selecting. So the 4.5 is for a mid-range greenhouse gas emissions. The 8.5 is for the high estimate. So those are choices that you can then model, select, and click done. The model should be rerunning in the background. And hopefully, if everything works, in the end, when we click our compare function, we should have a summary that is based, that has 2 views, a hydrology view and a water quality view, and has scenarios color-coded for each of the scenarios that I just ran, that also provides summary statistics for the modifications that we added to our project. And you can then visualize the monthly average estimate for stream flow, for surface runoff, for subsurface flow, point source, we're not predicting future point sources of evapotranspiration, and precipitation. All right, in the case of precipitation, we really just have the 1960 to 1990 data and the 2080 to 2099 data. So there's only 2 colors visible to the eye, but all 4 scenarios have precipitation under there. So that's for water hydrology. And we also have a water quality tab where you can look at the total load estimate for sediment, nitrogen, and phosphorus relative to the differences we see. If you're logged in, you can then share your project by turning on link sharing, copying the link, and sending it to a colleague. If you copy the link and send it to a colleague, they cannot edit your project. your project is safe and can only be modified by you. If you connect your account to HydroShare and turn export on, you'll be asked to submit a title and an abstract and a keyword, and then the software will send your project to this third-party resource called HydroShare, where you can share it, but you can also share it and basically give it to somebody so they can modify your project and own its derivative without affecting your source project. But that's probably subject for another time period to go into details on how to do that. Next, I'd just quickly like to jump back out and give you another example with a new project and run through the site storm model. So for this example, I'm going to upload a file, assuming that you all have some knowledge of GIS and ArcGIS, and you know what a shapefile is or a GeoJSON. If you have a polygon that you're working with and you don't want to redraw it here in Model My Watershed, you can save the shapefile in a zip file that contains all of the relevant shapefile components. And so I would just quickly show you what that means. So here is the zip file for a shape in ArcGIS that contains all of the other related files, but ultimately it's the shape file that we're most interested in. So I have this zip package, and once I select upload file here, you can see that it says drag or drop or select a file. I'm just going to go grab my shape file, or my zip, and bring it in here and drop it in the box. And as I do that, the polygon within the shapefile will be ingested and used to start analyzing the project area, similar to what we have already done, but with the HUC8 feature. And so you have all the summary statistics that we saw before. This time I'm going to go to Model, and I'm going to choose Site Storm Model. The Site Storm Model, remember from my introduction, is a 24-hour storm event on this parcel. So the first thing to note is we have a precipitation slider up top here that ranges from 0 to 10 inches for a 24-hour rainstorm. This simple site storm model then partitions the precipitation into evapotranspiration, runoff, and infiltration using a couple well-known algorithms. TR55 was developed for agricultural and more natural landscapes, and SLAM for the more urban landscapes. So we see a bar chart for a 1.9-inch rain event, giving us the inches for infiltration, runoff, and evapotranspiration. Now I'm going to dial this up to something that's more close to maybe a 2-year return interval storm event. I know at Philadelphia Airport, the long-term 2-year return interval storm is about 3¼ inches over 24 hours. And we can see the runoff now is measurable, or it predicts a measurable amount at 0.2 out of the 3 inches for this landscape. We also have this connected to a water quality model. This is the EPA's spreadsheet tool to predict loadings for nitrogen, phosphorus, and sediment. So it's a simpler model. It's a shorter term look at it, 1-day storm event. But we also allow the user to change things in the area. The choices are different. It doesn't perfectly align with the choices you have in the watershed multi-year model. But you can modify land cover. To do this, you actually draw over the top of an existing land cover. I happen to choose almost entirely forested landscape. But say we were interested in protecting this parcel and wanted to have some information. Hey, if we don't protect it and this land gets developed, what might be the changes that could occur? So say you might have a hotel that might be proposed for this area, or a shopping center that might generate impervious surfaces that account for 50 to 79% of the area you draw. So we select that tool and we start drawing. Okay, I think my hotel might go in over here, on the ridge, and I draw my polygon to a size that I feel is reasonable. Double click to close the polygon. And the model starts updating, and now we have implemented developed medium intensity, right? And I'm going to switch my microphone because I think I'm low. Okay, hopefully everyone can hear still. So just like in the watershed multi-year model, we can compare our scenarios and look at
Dave, you are on mute for some reason. Your voice is cut out. Dave, can you hear me? I think you are on mute for some reason. Your voice is cut out.
and I had alluded to estimating water quality benefits for land preservation. We've been doing this for a bunch of projects for land preservation in the Delaware with this modeling approach. We're modeling a wide range of conditions to bound the possibilities of the lack of forest protection on a parcel. And we've been using that site storm model, running scenarios that include developing it at a best professional judgment level, developing it to 100% open developed, low density, medium density, high density. So many different scenarios. And this is an example of a parcel where we've implemented developed high intensity land for a portion of this parcel. We do that for a wide variety of scenarios, and now we've generated a range of possibilities for all of these scenarios, with the best professional judgment of development all the way to the right. Otherwise, I've arranged these sort of sequentially what we would hypothesize to impact runoff, with a little bit of development to a maximum amount of development. We can also look at those patterns for water quality. We did this for about 46 parcels throughout the Delaware. This just gives you the average of all those different types of parcels. And perhaps, am I still muted? Doesn't look like it.
Great.
Average, so ultimately by averaging and looking at the variation of all those different parcels, we can generate some average statistics and variability among the parcels for these scenarios. The top panel here is runoff in inches for a 2-year return interval storm event. The bottom panel is infiltration for that same storm event. Right, and then we can also add up the total volume from all 46 of those parcels and look at total runoff volume. If this is helpful if we want to make estimates for having to manage that excess stormwater from all those different parcels. Now we have a volume that, that we can manage. So the top panel is total runoff volume, bottom panel is total, the difference in total runoff volume from current conditions. And likewise, we can do that for total suspended solids on the upper left, total phosphorus on the upper right, total nitrogen on the lower left. So I know this was a quick and dirty example because of limited time, and I'm sure there's plenty to talk about with that sort of approach. But I'd like to leave time for questions, so I'll end it there, but also just share with you that the presentations made possible from the Stroud Water Research Center, as well as supporting the Watershed Congress, made possible in part by a grant from Pennsylvania Department of Environmental Protection's Growing Greener program to support this consortium for scientific assistance to watersheds. So if you need technical assistance and you're within the state of Pennsylvania, you can go to this website, c-saw.info, read more about it, and reach out and request some support from us, as well as our partners. So I'll end it there and thank, of course, the funders and thank you all for attending.
All right, big thank you, Dave. That was incredibly helpful and informative on what is an award-winning web app. So I've got a few questions already popping up on how people can best utilize this in their day-to-day lives, whether it be with restoration or education or citizen science field. There's a lot of uses for it. And our first question comes from a participant who is wondering, historically, we were able to develop a .gms file and then upload this to the GWLF program or the Mapshed to further calibrate and refine the variables. Are there any plans to continue this capability?
Yes, that capability is still available. And I glossed over that in because of time, and I think I might be having some network complications that might be slowing things down. So this is going back to the first project I did, showing the use of the watershed multi-year model, which I guess Michael's quite familiar about GWLFE and Mapsheds. That was the precursor to what we've incorporated into Model My Watershed. You can see right up top that you can still export this .gms file so that you can bring it into your desktop GWLFE application and do the modifications, further calibrate your.
For some reason, you've gone out again, Dave, on your sound, and I'm not sure why.
Okay, just a moment.
Oh, you came back. You came back.
Sorry about that, folks. So what, yes, you can download the GMS. No, you cannot upload a GMS file into Model My Watershed. That's the simple answer.
Okay. And if your network allows, we might have enough time for you to point out exactly where this feature is if they're having trouble finding it with the updates. We have one question so far left. And again, for any other folks listening, oh, another just popped up. We've got a few more minutes for questions, about 10 to be exact. So if you've got any while Dave is here, please pop on to that Q&A. All right, Dave. All right.
Yes.
So let me know.
So,
yep.
So I see something from Chuck Marshall here on TMDLs, total maximum daily loads are specified as concentrations, and Model My Watershed calculates runoff loads. Can one relate the two? So yes, you have access to concentrations as well using the watershed multi-year model if you're working with TMDLs and need that. So I didn't go into that detail, but you can see, you know, loads, loading rates, mean annual concentration, mean low flow. If you're doing this in the state of Pennsylvania, just note that the state of Pennsylvania has been working the TMDL program previously with the use of Mapshed and GWLFE model. And the watershed multi-year model is just that. It's the next generation of that program. So this is also something that Pennsylvania DEP continues to use for their TMDL modeling. I think they accept this in some of their PRP proposals, pollution reduction plan proposals. So there's that bit of information.
Great, thank you, Dave. I'll take this other question that we have. We've got 2 in the queue right now. The first is about TMDLs, which are specified as concentrations.
Oh, that's the one I just answered.
Oh, wait. Yeah, you're right. Okay. So then, yes. Okay. And the next one is there any model studies for Great Marsh in northern Chester County, published with interpretation?
That answer I won't be able to give you. I'm not sure, Jim. Certainly if I come across any, I know who you are and how to contact you, so I can share those if I come across any.
And that concludes any questions I see. We've got a few more minutes, so let's give folks a second to kind of catch their breath and see if there's anything else they're wondering. The great part about this app is its versatility. So as Dave kind of navigated for us, there's a lot that you can do with it depending on your field of study, whether you're a watershed professional or you're actually working in education.
I guess I would conclude by just saying this is ongoing development of this software. So, you know, depending on funding, we have updates that occur. So if you see something that you think is useful for us to consider, I'd encourage you to share your thoughts. Let's see if I go back to Wiki Watershed. We have a contact page. So there are ways in here to, one, report bugs, but also share your thoughts for future features, or just ask questions about how something works. Before you ask questions about how something works, we do have a frequently asked questions portion on the website. So check the FAQs first.
And Dave, while we see if we have any other questions trickle in, I'm wondering, what if, hypothetically speaking, someone said, you know, Model My Watershed seems like an awesome tool as part of the Wiki Watershed toolkit. It may be a little advanced for the kids I'm working with, or even adults. I want to acclimate them with a version that is a little more of a caricature, a little more cartoonish, more of a 101. Is there anything like that that exists?
Yeah, so, you know, in my presentation, I presented this more towards the conservation practitioner or watershed practitioner out there. But in fact, we started the development of Model My Watershed really as an education platform for middle and high school students and undergraduate students. So we have ongoing projects to build curricula for teachers to use in schools. So we have a curricula page that really brings things down to a basic introductory level. And there are, you know, tutorials and videos, as well as, you know, other example projects that you can work through here. And I know Mandy's involved in some of this, so one could reach out to her as well for further explanation of these resources.
Absolutely. I don't see any more questions, so I wonder if it's worth leaving you with the main Model My Watershed page, where they could, if they so choose, explore that further. And the runoff simulation is there linked as well as a great tool if they wanted to explore further. Yeah,
this is a nice learning cartoon that helps one understand the basic principles of runoff and infiltration. It's fun to play around with as you change land covers. The system dynamically, the graphic dynamically updates. There's a precipitation slider to put greater intensity storm event through this square of land or less. You can change land cover. You can go from high infiltration soils to very slow infiltration soils and see how infiltration, runoff, and evapotranspiration change. And that is called the runoff simulation.
Brilliant. So to not take up any more of your time, I think it is perfect now to come to a close with the Watershed Congress. If we see any more questions pop up in the next 5 minutes, we're happy to take them if time allows. But for now, as we wrap up our session, I do want to take a moment to thank our speaker, once again, Dave Arscott, for taking the time to share his research with us and everything he knows about the latest updates and improvements to Model My Watershed. This is the last day of Watershed Congress presentations. We do have one more later this evening from 5 to 6 p.m., but we also encourage you to tour the Watershed Congress's virtual exhibit hall. All in one place, you can find more information about our supporters, like the Stroud Center, opportunities to connect, and other resources for your work wherever it may be in the world. We do encourage you to go into the chat. I did link that virtual exhibit hall if you want to check it out one last time this week. And as another reminder, all recorded presentations like this one will be made available on the 2020 Watershed Congress playlist on the Delaware Riverkeeper Network's YouTube channel. Some pre-recorded content may already be there, but you will receive an email in about a week when presentations like this one are posted at that YouTube channel. Lastly, we really hope this session sparked new and maybe familiar enthusiasm in freshwater research that will continue to burn brightly in this evening's last session, but also wherever you may be right now, it will follow you throughout this week and beyond. So please check your email or calendar if there's any other invites you might have. And in the meantime, we hope to virtually bump into you another time during COVID-19 and beyond. And have a great afternoon, everybody.
Thanks, everyone.
Thank you.